continue. Okay, so guys, I'm just going to run you through a couple more problems. We're just going to do these first two, and then we'll do something called perfect square trinomials. We'll do a little bit of rational stuff, and then we'll start talking a little bit about lines. Okay, factoring. Guys, y'all agree the number in front of that x squared is a 1? Okay, remember, these should be the easy breezy cover girl problems I'm looking for, right? Bless you. Look, so that's an x squared, so I'm going to put x and x. Y'all, I'm looking for two numbers that multiply to 16, but if I were to add them together, I would get an 8. What times what gives me 16 but adds up to 8? 4 and 4. Okay, so look, I'm going to put x plus 4, another x plus 4. The reason why we call this perfect square trinomials is because those guys match up, and we can write it as x plus 4 squared. It's just a coincidence that we ended up getting the same thing twice. But what I want to ask you is, the way I approach this problem, didn't we do it the same way? Didn't we just say what two numbers multiply to the last one, add up to the one in the middle? It just happened to be the same thing twice, right? There's no big deal about it. It's just, oh, look, there's a coincidence, right? Okay, look, I'm going to do the same thing for this next one here. 4x squared plus 20x plus 25. Guys, I'm going to go with method 1 because it seemed like more people liked method 1. So remember, I'm going to open this up here. If I want to get 4x squared, what do you think I should put in the front? If I want to get a 4x squared, what times what's going to give me a 4? Okay, we can go 4x and x, or we can go what? 2x and another what? 2x, okay. Y'all, look at the last number. What times what is going to give me 25? 5 and 5, okay. So that's positives, and so is that. So I'm going to make both of those there positive too. Now, remember, guys, this is the guess and check method. I'm going to check to make sure I did this right. Well, I already know that 2x times 2x is going to give me 4x squared. Okay, let's check the middle piece. What's 2x times 5? 10x. What is 5 times 2x? 10x. If I add those together, what do we get? 20x. Is that what we wanted to get? There we go. Look, 2x plus 5, 2x plus 5. Guys, can we write that as 2x plus 5 squared? I'm not doing anything different. The only thing that they're pointing out here, guys, is sometimes you get the same factor twice. You can write it once for this way. The process, we still did it the same way. We still did it the same way. Okay, let's do this last one because it should be an easy, this one here, because it should be an easy breezy cover girl problem to do. Let's try it to see if it works. Okay. So notice, y'all, the number here is just an x squared, so I'm going to put an x and an x. I'm going to ask you a question. What numbers do you know multiply to 81? 9 and 9, right? But negative because look at the sign, look at the sign of that 18. What's the sign of that 18? Negative. So look, guys, I'm going to go minus and minus, right? Because a negative 9 times another negative 9 still gives me that positive 81, right? If I have the same factor twice, can I write it like this? Can I write x minus 9 squared? Okay, that's all they're telling me. Okay. All right. Guys, I'm going to skip this one here, again, just for the sake of time, but I am going to scroll down a little further to this part here. Okay, the difference of squares, y'all. One thing I want to mention about the difference of squares, number one, in the middle, there needs to be a minus, okay? The reason why we call it the difference means we're subtracting. So in the middle, there needs to be a minus. The other thing is the first piece and the second piece have to be perfect squares. I want you to notice, number one, I have a minus. That's a perfect square because there's a square on it. So is that. This is what we're going to do. We're going to open this up. We're going to say, what times what would give me x squared? X and x? Okay. What number times itself would give me 49? Okay, 7 and 7. Guys, one of them is going to be minus, one of them is going to be plus. Because the formula right here, guys, says one of them is minus and one of them is plus. And that's all you're going to have to do. Now, I want to mention something here, guys. If I wanted to check my answer, right? I know that I could say x times x. I know that's an x squared. What is x times 7? 7x. What is negative 7 times x? Negative 7x. What's a negative 7 times a positive 7? Negative 49. Would those guys there in the middle cancel? Okay, look, that's what we had. It's going to be the same thing twice, except the middle piece, one's going to be plus, one's going to be what? Minus. Okay. Look, y'all, let's try this one the same way. What number times itself would give me a 4x squared? 2x and 2x. Okay. What number times itself would give me a 25? 5. Guys, one of them is going to be minus, and one of them is going to be what? Plus. Every single time. Every single time. One will be minus, one will be plus. Okay. I'm sorry, say that again? Oh, okay. Why did I use 4 and 1? Because in order for this thing here to work, it's always going to be what number times itself, right? Times itself. That's the other reason why I didn't go 1 and 25. You see what I mean? So it's going to be, if it's 4, it's going to be 2 and 2. If it's 25, it'll be 5 and 5. Excellent question. Guys, look at the next one here. Yes, ma'am. Yeah, 2x minus 5 and 2x plus 5. Guys, look at this one here. What's the first number that I have? 36. What times what gives me 36? Okay, so look, guys, I'm going to put 6's in the first spot. Okay, y'all, one's going to be minus, one's going to be plus. What times what is going to give me x squared? X and x, right? Okay, why did I put the 6 first? Because what number came first? That's why. Okay, guys, remember what we said? In order for this to work, the first piece and the second piece got to be squares, and the middle has to be a what? Has to be a negative. What do we have here in the middle? Okay, guys, what we say for this one, we say it's not factorable. It doesn't work, y'all, because in order for me to be able to do that thing, the middle piece has to be a minus. Okay, if it's a plus, I just can't do it. And we just say it's not factorable or it's prime. It just can't be done anymore. There's nothing I can do with that problem. Okay, there's nothing I can do with that problem. All right, so let's do these last two, and then we will go on to something a little bit different. Y'all, I'm going to ask you a question. Before I start doing what we've been doing so far, is there anything I can factor out of both of them? What do they both have? Okay, how many x's we're going to take out? 2. Okay, so look, we're going to take out an x squared. Y'all, before I go any further, is there a number that goes both into 81 and into 36? 9. Okay, so look, I'm going to do this, y'all. Okay, my question to you, how many times does 9 go into 81? 9 times. If we had an x to the 4th and we took out 2 of them, we're now left with an x what? X squared. Okay, guys, how many times 9 go into 36? 4, right? We had an x squared, but we took it out. So far, are we doing okay? All right. Look, I'm going to leave that 9x squared alone. What I want you to do for me right now, look at this piece. Okay. What times what would give me 9x squared? 3x, right? Wouldn't 3x and 3x give me 9x squared? Because 3 times 3 is 9? Okay. Guys, what times what would give me 4? 2. Everybody agree one's going to be minus and one's going to be what? Positive. Okay. So what I want to mention here, guys, is before I use that little rule that we've been doing, if there's something I can take from all of them to begin with, I want to go ahead and do that. Okay. All right. Let's take a look at this last one that I got here, guys. 25x squared minus 144y squared. I know I got big numbers here, guys, but what I want to mention here is there any number that goes into both of them? I don't think so. Okay, so look, let's do this. If that's a 25x squared, what do you think I'm going to put in the front? What times what gives me 25? 5. And it's 5x, right? Okay. What are we going to put at the end? Does anybody know what times itself would give me 144? With a y? One of them is minus and one of them is what? Plus. Okay, guys, I'm going to show you something here on our multiplication table. If I look at my multiplication table, guys, the one that's in our, that I have the little link for, if you look along, where is it? Right here, along the diagonal, those are all the perfect squares. So if I say what times what's going to give me 144, it's going to be 12, right? If I said what times what's going to give me 256, it's going to be so on and so forth. Does that make sense? So that table, guys, again, what I would tell you to do is, I know the test is tomorrow, but study your table a little bit tonight. Okay, study your table a little bit tonight. Now, guys, the other thing I would tell you is this. If you're still uncertain, go 144. This button right here is my square root. What's the square root of 144? 12, right? You can always do that. So if you have a number here and you don't know what times what would give you that, just use your calculator, right? So if I had 256, what's the square root of 256? There it is, 16. Okay. All right, I'm going to skip that one, guys. I'm going to go to this next part here. Again, I just want to make sure we have enough time to cover everything. Okay, so guys, the last part, or the next part I'm going to talk about here, y'all, is simplifying rational expressions. Okay, what are we going to do? We're going to factor, we're going to cancel common factors. Now, y'all, for some of these problems, we did a little bit of this yesterday. Let me ask you a question. Does 4 go into 8? How many times? 2 times. Okay, I want you to look at my powers, y'all. Where do I have more k's? On the top or on the bottom? On the top. On the top, I have 3. On the bottom, I have 1. If I subtract, how many k's am I left with? 2. Is that one of my choices? There it is. Right? That's all I'm doing here. I'm just simplifying it out. Again, we did a little bit of that part yesterday, right? I'm sorry? Okay, you always subtract because, remember, we did this yesterday, right? Remember what k to the third means. Doesn't k to the third means that there's 3 of them and there's 1 on the bottom? Wouldn't this k here cancel with that one? And how many k's am I left with? There you go. Right? When you're dividing, right? When you're dividing, you subtract the powers. Excellent. Guys, what we're trying to do here, when you were a kid, did y'all ever play that game Memory where they have the cards, they're all face down, and you pick it up, there's a man with a hat, you got to find the other man with a hat, you turn them up? You know what I mean? Okay. What we're trying to do here, guys, same kind of thing. If anything on the top matches up with anything on the bottom, we're going to cancel it out. What is exactly the same thing on the top as it is on the bottom? But not just the y, the whole thing has to be exactly the same. The y minus 3. Let's cancel those out. If we cancel those out, what am I still left with on the top? Y plus 6. What about the bottom? Okay, is that one of my answers? There it is. Now, guys, when I'm going to cancel something, they got to be exactly the same. So I can't, guys, one thing I also want to mention, I can't cancel individual pieces. So I can't say, well, can I get rid of this y with this little y here? No. If it's in parentheses, you got to think about that as one like family unit. Okay. The only thing you're going to cancel is when they're exactly the same. Look, let's do the same thing here. I'm going to ask you a question. We're going to see if we can do any factoring. Y'all, look at the upstairs. It's x plus 6y. Can I take anything from x and 6y? Do they have anything in common? Just look at the top part, though. Is there anything here and here that are the same that I can pull out of both? No. Okay, x plus 6y. We're going to leave it alone. I want you to look at this guy. Is there a number that goes into both? 3. Okay, look, y'all. If I take the 3 out, if I take the 3 away from here, what do I still have? X. And 3 goes into 18? 6. With a 1? Okay. Are we okay in how we got to where we are? Okay. Are you okay how I took the 3 out of both of them? Because if I take the 3 out of here, don't I still have an X? And if I take 3 into 18, doesn't that go in 6 times? Right? Now, Guys, is anything on top exactly the same as it is on the bottom? X plus 6y, x plus 6y. Where is the 3 right now? On the top or on the bottom? On the bottom. Okay, guys, if I don't see anything left with on the top, it's always a 1. Is that one of my choices? There it is. Yeah, because it's on the bottom, right? So all I'm trying to do here, let me just kind of scooch this to the side. X plus 6y, 3x plus 18y. All I'm really doing here is I'm saying, look, is there anything that goes into both of them? Yeah, the 3, right? So that's why I can write x plus 6y. Because again, 3 times x, 3x. 3 times 6y, 18y, right? And I still have this x plus 6y up here. So then we say, look, this guy here, that whole thing is going to cancel with that whole thing down there. But you see how the 3 was on the bottom? It has to stay on the bottom, right? And if I don't have anything on the top, y'all, I'm always left with a 1. Well, 4 was at 3 to begin with. So it has to stay on the bottom, right? It's got to stay on the bottom. Look, y'all, let's try something similar. Let's try this one here, okay? I'm going to ask you a question. Look at the top piece. Is there anything you can factor out of the top? 5. Y'all, if we take out a 5, what are we still left with inside the parentheses? X negative 7. Everybody agree? Okay. Now, look at the bottom part. Is there a letter that they both have in common? X. If I take away the X, what am I still left with inside the parentheses? X minus 7? Okay. Can I cancel those X minus 7s? Okay. If I cancel them, what am I still left with on the top? 5. What am I still left with on the bottom? Is that one of my choices? There it is. Is that a little bit better? Was that one a little bit easier than the one we just did? Good. Good. Okay, y'all, let's try this one here. I'm going to go about it the same exact way. Okay. I want you to look at the top part. Okay. What number goes both into 3x and 15? A little slower, 3, right? Good. Okay. Look, if we take out the 3, what am I still left with right here? X plus 5? Okay. Y'all, is there anything I can take out of the bottom? 5. If I take out that 5, what are we still left with? X plus 5. Anything here going to cancel out? Okay, what am I still left with on the top? And on the bottom? 5. Guys, let me ask you a question. These last two, did they get a little bit easier? Good. Good. Okay. So, y'all, for the next part here, I'm going to kind of, question? I'm going to kind of go through this part, guys. I'm going to skip some pieces. I had some copies made. And Ruth, I know you're at home, Ruth, but I wanted to mention this real quick. Let me see where it is. Okay, this piece right here. So just to give you a heads up, Ruth, I know you're watching online, or those of you who decide to watch later, the handout that I'm going to give to you guys in a little bit is right here. So if you click on this, it pulls up this guy. We're going to go through some of this in a little bit, okay? So with this part here, guys, I'm going to do some pieces, and then we're going to do some of that handout there. But I don't know how many of y'all have or remember or have ever seen, how do you plot points? Okay, so guys, first thing is here, all we have done is we took our paper and we cut it up into 4 pieces, okay? What we do, guys, y'all remember Roman numerals from elementary school? Maybe you heard of Roman numerals before? Okay, we call this one 1, we call this one 2, we call this one 3, we call that one 4. We never use Roman numerals, guys, except for whatever reason when we do this part. But all I did is I cut that piece of paper into 4 pieces. Okay, what we're going to do, guys, we're going to plot points. Every point, y'all, is going to be in the form X and Y, okay? The first number, y'all, is going to tell me how to move either left and right, and the second number, y'all, is going to tell me how to go either up or down, okay? And so this is what we're going to do. We're going to plot our points, okay? So look, guys, I'm going to use this light blue. I want to plot the point 2, 3. Okay, I'm going to always start here in the middle. Okay, so I'm here in the middle. The first number tells me how to go left or right. It's a positive 2, so I'm going to go to the right 2. I'm not going to put a mark or anything, guys. I'm just kind of chilling right here. My second number is a positive 3. I'm going to go up 3, and there's my point. Did that make sense how I did that? Okay, look, let's do the next one. The next point I have, y'all, is the point negative 3 and 5. Again, I'm going to start off right here, y'all, in the middle. The first number is going to tell me how to go left and right. The second number is going to tell me how to go up and down. So I'm going to go to the left 3. I'm not going to make a mark. I'm just chilling right there for a little bit. Now I'm going to go up. How many spaces? Here's my second point. Okay. Look, y'all, 2, negative 4. Again, I'm going to start back over here in the middle. The first number tells me how to go left and right. The second number, y'all, tells me how to go up and down. I'm going to go to the right 2. I'm just going to chill right here for a little bit. My second number is a negative 4. Which way should I go? Boom. There's that point. Okay. Look, y'all, I got another one here. Negative 3, negative 1. I'm going to start here in the middle. I'm just chilling here for right now. First number is left and right. Second number is up and down. I'm going to go to the left 3. I'm not going to make a mark. I'm going to chill there for a little bit. My second number is a negative 1. Up or down? There it is. Okay. Now, look at the next one. 0 and 2. The first number, y'all, tells me how to go left and right. The second one tells me how to go up and down. If the first number is a 0, I'm not going to move left and I'm not going to move right. But my second number is a what? So I'm going to go up 2. Does that make sense? Okay. Last point, y'all. Negative 4 and 0. I'm going to start here in the middle. The first number tells me how to go left and right. The second number tells me how to go up and down. My first number, y'all, is a negative 4. So I'm going to go to the left 4. What's my second number? 0. So that means stay right there. Did that make sense how we're able to plot our points? Okay. So this is how I plot points. Guys, the other thing I want us to be able to do is if we had points, could we find what the coordinates of those points are? Okay. So what I mean by that, scroll to the next problem here, y'all. This one right here. Okay, what I would like for us to do here, guys, is I want us to find the coordinates of each of the points, okay? Now, we're going to start off real slow. We're going to look at point A. Where is point A? Right in the middle. So what would you say those numbers are going to be? 0, 0. There you go. Now, guys, I picked this problem directly out of a book. I'm not trying to confuse you here, but look at the point B. If I'm right between 3 and 4, 3.5. Thank you very much. 3.5, comma. Did we go up or down after that? So it's going to be 0. Excellent, y'all. Let's look at C. Remember, guys, first left and right, then up and down. 3 and 2. Excellent. Okay. Let's look at point D, you guys. Okay, remember, first left and right, then up and down. I could have stayed home today, guys. Look at point E. Negative 2, negative 2. Everyone agree? Okay, guys, we got 2 more. Let's look at F. F is, remember, first left and right, then up or down. Did we go left or right at all? No, good. 0 and negative 1. Excellent, y'all. And one last point, point G. 2 and what, negative 1? There you go. Question? Are we good? Oh, okay, now we're good, we're good. Awesome. Guys, I'm going to skip this one, but I'm going to do the next one here in my list. Not that one, this one here. This one here with the one about the cost in dollars and computer desks. Okay, so I want you to look at this problem here, guys. This is going to be an evaluating type of problem. Okay, look what it says. The cost in dollars Y. So Y is how much things are going to cost of producing X computer desks. X stands for how many desks we're going to make. and they give me an equation here, y equals 80x plus 5,000. Okay, they want me to make a table. So first off, the first thing I'm going to do, I'm going to write down this piece right here, 80x plus 5,000. Okay, the first time, guys, they're telling me that x is the number 100. What we want to do, we want to figure out what y is going to be. So y'all, when we were here yesterday, one of the things we did when we came back from our break yesterday was we talked about evaluating. What I'm going to do, guys, is everywhere I have an x, I'm going to plug in what number? 100. So look, let's go like this. 80 times 100 plus 5,000. Anybody have a calculator? Does anybody know what 80 times 100 is? 8,000. Y'all, do y'all know what 8,000 plus 5,000 is? 13,000. Okay, right here, guys, I'm going to write 13,000. Before I go on, are you all okay how we came up with the 13,000? Okay, what I want to emphasize now is what does that mean? That means if we're going to buy or we're going to make 100 desks, it's going to cost us how much money? $13,000, okay? Look, guys, we're going to do that problem again. But now we're going to do it very good. Now we're going to do it with 200. So look, we're going to take 80 times 200 plus 5,000. Okay, y'all, anybody know what 80 times 200 is? 16,000? Okay. Y'all, what's 16,000 plus another 5? 21,000. Okay. So think about what that means. If we're going to make 200 desks, that's going to cost us 21,000. Okay. Guys, we're going to do this a third time. And now what number are we going to plug in? 300. Okay. Okay, anybody know what 80 times 300 is? 24,000. But if we add another 5, bless you, 29,000, bless you. Okay, so look, guys, we made 100 desks, it cost us 13,000. We made 200 desks, it cost us 21,000. We made 300 desks, it cost us 29,000. Okay, now I want us to take a look, guys, at part B. Part B says, find the number of desks that can be made for $8,600. Okay, so guys, I want you to notice something. Now we know how much money we have. We want to go backwards and figure out how many desks did we need to make so that it was going to cost us $8,600. Okay, guys, do you agree that my answer should be smaller than 100? Okay, why smaller than 100? Because at 100, it was going to cost us how much? 13,000. We have less than that, right? So it's going to have to be less than 100. Okay, this is what we're going to do, y'all. We're going to look at the equation that we had, right? The equation they gave me was y equals 80x plus 5,000. Now, we know that the amount of money we have is 8,600. Guys, the y stands for the amount of money. So I'm going to put 8,600 equals 80x plus 5,000. If I wanted to solve this problem for the letter x, if I wanted to get my x by itself, how would I get rid of my plus 5,000? We'd subtract it. Okay, we did this yesterday. Okay, so I'm going to take my calculator, guys. 8,600 minus 5,000, 3,600. Okay, I'm going to do it over here because I'm kind of running out of room. Equals, I still have an 80x right there. Y'all remember what the last step was? Divide. Let's divide everything by 80. And we're going to figure out that we can make how many desks? 45 desks, right? And then we go. Okay. Guys, I'm going to talk to you a little bit about intercepts, okay? I'm going to talk to you a little bit about intercepts here. What I want to mention, guys, when it comes to intercepts is we have something called the x-intercept, we have something called the y-intercept. The x-intercept, guys, is just where my blue line is going to hit the x-axis. Okay, so I want to mention something, guys. Look, that's my x-axis. If I wanted to find what we call the x-intercept, I'm looking for that point. Can anybody tell me what are the coordinates of this point right here? Remember, the first number is left and right, and the second number is up and down. Very good. That one's going to be -4, 0, right? Because that's first left and right, y'all, and then up and down. Now, we also have something called the y-intercept, okay? The y-intercept, y'all, is just where it hits that line. So if I were to ask you a question, and I were to say, could you tell me the coordinates of that point up there at the top? What would you say that point? 0 and 3, right? Okay, perfect. All I'm trying to look for right now, y'all, are those particular points. Okay. Let me scroll down a little further. Let's do another one similar. Let's find my x-intercept. Okay, x-intercept, y'all, where it hits the x-axis. In this case, we have two of them. Okay, can anybody tell me the coordinates of that point? -2, 0. Perfect. Y'all, what about the coordinates of the other one? Perfect. Okay. Now, let's do the y-intercept. Remember, the y-intercept, guys, is where it hits the y-axis. There you go. Are we okay in how we found the coordinates for those points? Okay. We're just looking for the coordinates where it crosses those things. Okay, guys, I'm going to skip this one because it's pretty much the same thing. That one también. And I'm going to skip over this part right here for a minute, y'all. I'm going to show you where I'm going to get into start picking up again. Okay, here we go. We're going to talk about something called the slope of a line, y'all. Okay, so I'm scooching down a little bit again, just for the sake of time. Okay, so some of you may have heard the term the slope of a line before. Some of you may have heard that term. And so, guys, the first thing I want to mention is what the slope of the line tells me. It's a rate, okay? It's a rate of change. And it tells me how my points are going to line up, okay? So there's a formula here, guys. And one thing I want to mention is when you're taking your test, guys, if there's any formulas you need to know, they're going to provide them for you, okay? But here's my formula. The formula says y2 minus y1 divided by x2 minus x1. All that means, y'all, the x1, y1 just means that I have 2 points. One of them is x1, y1. The other point is x2, y2. Why 1 and 2? Because there's 2 points. So this is the first thing I'm going to do, y'all. The first point that they gave me was -2 and 3. The second point that they gave me was 4 and -1. Okay. So because this is the first point, y'all, I'm going to think about those numbers as x1 and y1. Because this was my second point, I'm going to think of those as x2s and y2s. Okay. Now, it doesn't mean I'm going to do anything with the 2 or the 1. It just means those are how I'm labeling my points. Okay. Now, guys, what I want to do here is I'm going to write down the formula that I have right here. And I'm going to figure out how I can use that formula to find something that we call the slope of a line. Okay. Look, y'all, the first part of the formula says write down the number y2. Well, my number y2 is what number? -1. Then there's a minus, so I'm going to put a minus. There's always going to be a minus, y'all. Then it says write down the number y1. My number y1, y'all, is 3. Then it says take the number x2. My number x2 is minus my number x1, -2. Okay, guys, before I go on, are y'all okay how I wrote -1 minus 3, 4 minus -2? Okay, remember, this is my x1, that's my y1. That's my x2, that's my y2, right? What is the first part of the formula that told me to write down? It tells me to write down my number y2. Here's my number y2, it's -1. What do I have after that? I got a minus, so I wrote a minus. Then it says write down the number y1. Look, here's my number y1. Why am I calling those x1s and y1s, x2s and y2s? The first number is always x. The second number is always what? There you go. Then it says write down the number x2. Look at x2. x2 was the number 4. Minus, so I put a minus. Write down the number x1. x1 was the number -2. Okay, guys, I'm going to come back here real quick. Y'all agree that minus and minus make a plus? Okay, let me ask you a question on the top. What is -1 minus 3? -4. Okay, what is 4 plus 2? 6. Okay, I got one last question for y'all. Can I reduce those numbers into what? There you go. Okay, so look what we came up with, guys. We came up with a fraction, so we got -2/3. What does that even tell me? I'm going to show you right now. Y'all, if I wanted to draw this point here on my graph, from the middle, if I wanted to go to the point -2 and 3, where would I move first? Left 2 and then up 3. You guys agree that's where the point -2, 3 is? Okay, guys, what about the point 4 and -1 from the middle? 4 to the right and then 1 down. Okay, guys, what I'm going to try to do here is I'm going to try to connect those points real nice and pretty. Usually it does that. Never not. Okay, anyway, there's my line. Okay, so guys, let me show you what's going on with this line. When I have a line like this, y'all, the way I read the line is I read it from the left to the right. So if I'm coming from the left, to the right, would you say that line is going up or that line is going down? Now, look what kind of number we have. What kind of number? Negative. Okay, so if I have a negative slope there, it means that my line is coming down. The other thing that tells me, see how it's -2 over here? What that means, from this point, let's move down 2. 1, 2. Let's move to the right, 3. 1, 2. I kind of like it. I'll do that again. 1, 2, 1, 2, 3. You see that? How they're kind of line up there? Again, look. 1, 2, 1, 2. I know I kind of messed up with 3. 1, 2, 1, 2, 3. And I can keep doing that. 1, 2, 1, 2, 3. But that's what it's telling me. It's telling me how to move from one point to another. Okay. If my slope is negative, guys, my line's going to come down. When people say, how do you know your line comes down? You go from the left to the right. If you were up here, it's like you're going down a slide. Okay. Now, let's try the same thing for this one here. Okay. I'm going to go through a similar process, guys. This is what I want us to do. Look, -2 and 1, 3 and 5. That's my x1 and y1. That's my x2 and y2. Because it's always x, then y. Why am I using 1s and 2s? Because I got 2 points. The first point, the second point. Okay, second thing, y'all. I'm going to write down the formula. It's the same formula I had a little while ago. Okay. Excuse me. And I'm just going to go ahead and start plotting my points. Or doing my calculation. Guys, what's my number y2? 5. Minus, what's my number y1? 1. Okay. What's my number x2? 3. Minus, what's my number x1? -2. Okay. Let's do the top part. 5 minus 1 is 4, right? Guys, y'all agree that minus and minus make it what? Positive. Okay. Look, here's my answer, 4 over 5. Okay, guys, let's go ahead and plot those points. Anybody know where would I find the point -2, 1 from the middle? Where would I find the point -2 and 1? Left 2 and then 1 up, right? Okay, there it is. Guys, where would I find the point 3 and 5 from the middle? 3 right and then up how many? There you go. Okay, I'm going to try to draw this as perfectly as I can. Okay, remember guys, the way I read my line is I read it from the left to the right. If I was going this way, is my line going what direction? Up. Y'all, look at the sign of our answer here. Wasn't that a positive number? Okay, What this is going to tell me, guys, is I want to get from this point here to that point there. I can count 1, 2, 3, 4, and then I'm going to go 5 to the right. 1, 2, 3, 4, 5. And I can continue to keep playing that game each time. It just tells me how to move from one point to another. That's what the slope of a line tells me. Okay. Do what? I'm sorry. Yeah, but the top number tells me how to go up and down, and the bottom number tells me how to go left and right. Okay, so the top number says go 4 up, and the bottom one says go 5 right. Excellent question. Okay, so guys, I'm going to keep scrolling here. What I want us to do is, looking at this picture, guys, I want to see if we can find the slope of the line. Okay, so this is what I want to put, y'all. The slope of the line, y'all, a lot of times we call it the rise over the run. Sometimes we call it the rise or the fall, okay, depending if the line is going up or down. And the bottom number is always going to be what we call the run. Okay, so first question I want to ask you guys, if you look at that blue line, from the left to the right, is that line going up or is that line coming down? Coming down. So y'all, if it's coming down, the slope is going to be what kind of number? Negative. Okay, this is what I want us to do. I want you to notice that, y'all, they gave me a real pretty point right there, and they gave me another real pretty point right there. Let's count how many spaces down we need to move. Okay, so look, 1, 2, 3, how many? Okay, the top number, guys, -4. Now, from where I ended up here, I want to know how many spaces to the right I have to move. 1, 2, how many? There's my slope. Did that make sense on how I looked at it and found the slope? All I'm doing, guys, is I'm counting. Okay, I'm just counting here. All right, we're going to do a couple more to make sure that we're okay here, guys. Look at this line. Would you say this line is going up or down? Okay, remember, guys, we call it the rise or the fall over the run. In this case, guys, it's going to be a rise. I'm going to count from this point here to that point there. How many spaces up do I need to move? Let's count. 1, 2, 3, 4. How many? 5. How many spaces to the right do I need to move? There you go. There's the slope of the line. Okay. So far, so good? Okay, guys, if the line goes up, what kind of slope do we have? Positive. If the line comes down, negative, right? Okay. Guys, let me ask you a question. Look at that line. Is that line going up? No. Okay, so it's not what then? Hold on, wait. Go slow. If it's not going up, it's not what? Positive. Is that line going down? So it's not going to be what? Negative. What number is not positive or negative? Guys, that line that's going like this is what we call a horizontal line. It doesn't matter where it is. If it's a horizontal line, the slope is always going to be what? 0, because it's not going up and it's not going down. Doesn't matter where it is, whether it's down here or up here, it's still horizontal. Slope's going to be 0. Okay. Guys, look at that line. Is that line going up or is that line going down? Well, it looks like it's going up and down, right? Okay. Undefined, guys. If the line is vertical means it's doing this number. It doesn't matter where it is. As long as the line is vertical, it's going to be undefined. So when we said, is the line going up? Some people said yes. Is the line going down? Some people said yes. Miguel says it's doing both. I agree. It's going both up and down. If it's up and down, it cannot be positive and negative at the same time, so it has to be undefined. Okay. Okay, guys, I'm going to skip this part right here real quick. I'm going to get to the part that I think is the important part. I'm going to hold off. Okay, let me get to the important part. Okay, so guys, this part here is the part that I think is, out of everything here, again, guys, I'm trying to cut some of this stuff just for the sake of time. I'm trying to get to the parts that I think are going to be the most critical than what you're going to see tomorrow, okay? So first thing I'm going to do, y'all, right here, I'm going to write something called the slope intercept form of a line. okay? The slope-intercept form, y'all, looks like this. Y equals mx plus b. And I'm going to give you all some information, okay? M is the slope of my line. The point 0 and b is going to be what we, bless you, is going to be what we call our y-intercept, okay? Now, remember, a little while ago, we talked about what the y-intercept was. The y-intercept was just where on the y-axis did we hit the graph, okay? So, guys, let me explain the simplest way on how I'm going to graph lines using something we call the slope-intercept method. Number one, we're going to find the point 0 and b, and that's going to be my starting point, okay? So, guys, I want to ask you to do me a favor here. I want you to look at this guy right here, and I want you to look at this guy right here. What would you say the value of b would be equal to? Okay, so y'all, where I'm going to start, the first number is always going to be 0. Every time, every time. Siempre, siempre. The second number is going to be whatever number our number b was here. It's -1. My question to you, where would I find the point 0 and -1 from the middle? Where would I go from here if I wanted to plot the point 0 and -1? Down 1. Everybody agree down 1? Because the first number was 0, so I'm not moving to the left and the right. The second number is -1, so I'm going down. Guys, I want you to notice something. See how that's called the y right there? The first point you plot, y'all, is always going to be on that line, okay? So if your first point, if you're not plotting it on this line, you're already making a mistake. It's always going to be on that line, okay? Second thing I want to ask you, if m stands for my slope, I want you to notice something here. M is a number in front of what letter? What's the number in front of my x here? Okay, guys, I'm going to think about this as -4/1, because remember how we said it's either the rise or the fall over the run? If I don't see a number in the bottom, I can always write a 1, okay? So this is what I want to do, y'all. From that green point right there, I want us to use this number to find another point. Since the top number is a -4, should I go up or down? Down. Look, we're going to count. 1, 2, 3, 4. I'm not going to put a mark yet, though. Since the bottom number is a +1, we're going to go to the right. Okay. Look, guys. There's my line. That's how I graph it. Okay. Y'all, I'm going to do a handful of problems like this because I want to make sure that we're okay. All right. Again, I know it's a lot. I wish it was less, guys. I wish it was less. Part of it, you know, they made this class 4 days. You know, maybe a 5th day would have been better. But it is a lot. So I don't want to try to minimize and say it's not. I'm going to do some more problems like this, guys, so we get the hang of it, okay? Look, let me scroll down a little bit further. Let me see if I can find another one. Here we go. This is what I want us to do. Right here. Y equals -3x. Actually, you know what? I'm going to, sorry, guys. My bad. I'm going to come back to this one here. I'm going to just change this problem, though. I'm going to put y equals 2/5 with an x. I don't know, say -2, something like that. I'm just making it up. I'm going to show you how to do that in a minute. I'm going to show you how to do that in a minute. I'm trying to keep the first ones kind of simple, and then I'll show you one a little more complex. Okay, so look, guys, I'm going to think of this guy right here. Y equals mx plus b. Okay, number one, y'all, I want to find my starting point, which is always going to be 0 and b. Okay, so look, y'all, what is my number b in this case? Okay, so look, it's going to be 0 and -2. So if here I have this part right here, where would I find the point 0 and -2? From the middle. Everybody agree down to? Okay, y'all, remember, the first point is always going to be on that line right there because it's the y-intercept. Your first point should always be on that vertical line going up and down for the y-axis. Okay, second thing is, what I want to find now, y'all, I want to find my m. Remember what m is. M is the number in front of what letter? What's the number in front of my x? 2 over 5, right? Remember, y'all, we call this the rise over the run. What kind of 2 over 5 is it? Positive. Okay, so the top number is a positive 2. What does that mean I'm going to do? Up to 1, 2. Okay, I'm hovering right here. Since the bottom number is a positive 5, which way? 1, 2, 3, 4, 5, right there. And there's my line. Guys, let me ask you a question. Would you say that line is going up or down? Up. Look at our slope. Our slope is what kind of number? Positive, right? Okay, look, I'm going to scooch back. I'm going to come back to this one in a minute. Look at our slope here. Our slope here, guys, was what number? Negative. Look at our line. Did our line go up or down? And I am going to show you, guys, her question is, what happens if the line isn't written like y equals mx plus b? I'm going to show you that in a minute. Okay. All right, look, let's try just a couple more, guys, and then we'll be finishing up. Okay, y equals negative 3x. Let's do this, y'all. Y equals mx plus b, okay? So look, if I look at this guy here, y'all, and I look at the equation that I have, y equals negative 3x, number one, I'm going to look for my starting point. My starting point is going to be 0 and whatever b is. Look, y'all, b is the number over here. What's the number over here if I don't see it? Okay, so 0 and 0. You guys agree right there in the middle? Okay. Second thing we're going to do, we're going to find our m. Remember, y'all, the m is the rise over the run, the rise or the fall, depending on what it is. Everybody agree? Negative 3 over 1? Again, y'all, if it's a whole number, you can always write over 1. So if the top number is a negative 3, how should I move from that red dot? Down 3, and then to the right? 1. And there's my line. So far, so good? Okay. Let me see if I have one more. I'm going to hold off on that. Okay. Let me just do one last one here, guys, and then we'll do something a little bit different. Okay. Let's see. 4x plus 2y equals, I don't know, keep it simple, 6. Okay, look, guys, I want to do this one here. 4x plus 2y equals 6. I'm just making this one up, okay? Just making this one up. Now, remember, what I want to compare it to, guys, I want to compare it to y equals mx plus b. What letter is by itself here? Y. If I wanted to move this 4x to that side, would you guys agree I would go minus 4x? Okay, look, I'm going to do this here, y'all. This 4x and that 4x are going to cancel out. I'm going to drop down my 2y. Now, let me ask you a question. Are those right there like terms? No. So I'm going to leave the negative 4x and the positive 6 alone. I'm not going to do anything with them right now. I'm just going to leave them as they are because I can't combine them. Now, we said what letter here was by itself? Y. How would I get rid of this 2? We're going to divide everything here, y'all, by 2. So look, that 2 and that 2 cancel out. What's negative 4 divided by 2? With an x. What's 6 divided by 2? 3. Okay, guys, can I compare these two now? Okay, what is my starting point? My 0 and my b is going to be 0 and what? 3. Okay, what about my m? What is my m in this case? Negative 2 over 1. Can we go from there? Okay. So does that answer your question about how would I, if I didn't have it in that nice and pretty form, how would I get it in that form? Better? Yeah, yeah. Or just, yeah, no, you're, okay, perfect. Good, good. I'm glad we got that part cleared up, guys. Okay, so look, guys, before I do anything else, I have an additional handout that I'm going to give you. This is the part I want to go over for the next part, and then we'll do the last little bit, which deals with square roots. This stuff here, guys, is kind of similar to what we have in the other. These are probably with minor changes. But Again, I want to try to give you as much info as I can. Yeah, we're going to work on this one right now, the one that I just gave to you. So hold on, we're going to hold off on the other one for a minute. Okay, I'll get if there's any extras, guys, I'll get them for you guys in a minute. Let me see what I need. Okay, and let me do this. Okay, so guys, same thing we got here. Okay, remember when we were finding slopes a little while ago? We're doing the same thing here. The difference is these problems are in the context of kind of like a word problem type of setup, okay? And is it important to know how to find the slope? It is. It's also important to know how to do it in this context, and that's why I came up with these problems for you guys. So let's take a look here, guys. It says the graph below shows the data from a call assistance center, and the question says, at what rates are calls being handled? Okay, I'm just going to look at my picture, guys. Okay, at 10 a.m., how many calls did it look like they had? 30 calls. Okay, this is at 1 p.m. How many calls did they have now? 90 calls. Okay, guys, we want to figure out how many calls are they getting every hour. Okay, let me ask you a question. How many, if they had 30 calls and now they have 90, how many additional calls did they get? Okay, 60 calls, right? How much time passed from 10 in the morning to 1 in the afternoon? How many hours? How many hours? That's why I kept on asking the same question over and over, right? 3 hours, right? Because from 10 in the morning to 1 is 3 hours. Guys, how many calls are they getting per hour? Okay, now I want to show you guys something. When we came up with the number 60, didn't we really just subtract 90 minus 30? Okay, guys, I'm going to show you all something real quick over here. That's not what I wanted to do. Here we go. Okay, let me come back this way. Let me scroll más to the arriba. I'm going to scroll más up here. Okay, remember when we did these problems? I want you to look at the formula for my slope. What did I do with those numbers on the top? What's the operation I have right here? Subtract. What do we do with the numbers on the bottom? What's the operation right there? Subtract. Okay, look, I want to come back to the problem we just did. Okay, from 10 in the morning to 1 in the afternoon. I know this is not military, but y'all know military time. Wouldn't that be 1,300 hours? You ever heard of that expression before? Guys, if you go into healthcare, that's how they do their time come in. From 10 in the morning to 1,300 hours. Aren't we just subtracting? Isn't that a 3-hour time frame? Okay, what do we do at the end? We divide it. We really just did the slope of a line. Does that make sense? Because we took those numbers, we subtracted them. We took the numbers on the bottom, the difference in the time, we subtracted them. We found the slope. The rate is just the slope. Okay? Look, y'all, let's try this one here. Let's see if we can figure this problem out. It says the graph below shows the population of Cleveland. At what rate was the population changing? Okay, so look, they have it right here, y'all, in the year 2000. In the year 2000. Remember that? That was a long time. Remember that? With Conan O'Brien? Okay, that was a long time ago. All right, so some of you guys weren't even born yet, right? Oh, it's so weird. Guys, real quick, anybody here born in the year 2000 or later, like 2000, 2001, 2, 3? Oh my God. Oh my God. Okay. All right, so look, guys, in the year 2000, we had 475, what does that mean there if it says in thousands? 475,000, right? Okay, look, y'all, in the year 2010, what was the population here? 375? Okay, what was the difference in those two? 100,000, right? 100,000, because remember, it's in thousands, right? How many years have passed? 10 years. Okay, so guys, if we divide this out, I'm going to get 1,000. But let me ask you a question. Was the population going up or going down? Okay, negative 1,000. What does that mean? Every year, it was like 1,000 people left. Does that make sense? Why? Because the population is going which way? Going down, right? That's why it's a negative number. Okay. All right. Guys, let's take a look at another one. Again, I'm trying to make this as simple as possible here, guys. The following graph shows data from a recent train ride from Denver to Kansas. At what rate did the train travel? Okay, so look, guys, again, I'm not trying to confuse you. I pulled this out of a book that I taught of when I taught up in Austin, but it's same material, okay? At 3 o'clock, what number would you guess this to be? If it 275, right? 275. Okay, at 3 o'clock, we were at 275. This looks like at 5 o'clock, we were at what? 450. Could we take the difference in those numbers? Okay, so look, let's take that. 450 minus 275 is 175. Okay, remember, guys, that's miles because it tells you right here, miles. How much time passed from 3 to 5? 2 hours. Okay, so let me ask you a question. If we traveled 175 miles in 2 hours, could we figure out how fast we're going? Could we divide it by 2? 87.5. Wouldn't that be miles per hour? Okay. I had asked y'all a little while ago if any of y'all had taken Math 100. Some of us had. What I want to emphasize, guys, is even if you haven't, what I want to emphasize is that we actually know how to do rates because we've thought about them before. We can do these problems here. This is the same thing as finding the slope of a line. But when we do it like this, sometimes it makes more sense than just taking two random numbers and plugging them in. Okay. Let me keep scrolling down here, guys. Okay. So guys, what we're going to do here, this, like the problems we just did right now, and these next couple of problems were problems that I saw that were on the test, okay? And they were in this kind of a context. So I want us to think about this problem for a little bit, and let's see if we can't figure this thing out. Guys, it says the Bettis family is thinking about switching cell phone providers and is interested in a family plan. The plan has unlimited talk, text, and data for a fixed cost, and the total cost is based on the number of phones for each family. Okay, I'm going to stop right there. So what is the problem telling me? We're going to have unlimited talk, text, and data for a certain amount, fixed cost, meaning it's either going to be like $70, $100, $9, it doesn't matter what it is. But they charge me based on how many lines I have, okay? So whatever, all the unlimited talk, text, and data, it's always going to be like, say, 80 bucks. And then if they charge me, say, $50 for each phone line, then if I have 3 phone lines, that's 3 times 50, 150, so on and so forth. But the 80 bucks is going to be standard. Look what it says. It says, use the table below to answer the following questions. Find the rate that they charge us per line. Well, I know they charge me $110 when I have 2 lines, but they charge me $140 when I have 4 lines. What I want to know is, do we know how much more we paid in going from 2 phones to 4 phones? Do we know how much more we had to pay? We paid how much more money? $30. Okay, we paid $30 more. How many more phones did we get? 2 more lines, right? Okay, so if it's $30 for 2 lines, how much are they charging me per line? 15. Okay, now, y'all, before I go on, sometimes people say, why didn't you just take 110 and divide it by 2? Well, look, guys, if I take 110 and I divide it by 2, that was what, 55 bucks? But somebody might say, well, why don't you take 140 and divide it by 4? It's different. You see what I mean? So I can't just do it that way because I have to know, well, look, if I got 2 more phones, I paid another $30. That means that they're charging me $15 per phone. Okay. Now, we want to figure out what is the fixed cost. Sorry, I put the 15 in the wrong spot. Sorry about that. Okay, $15 per line. Okay, how much does it cost for the general service regardless of the number of lines? Okay, look, guys, we already know that if they charge me $15 a line, if I had 2 lines, how much would I have paid? 30, right? Because we're going to take 2 times 15. That should give me 30 bucks, right? But my bill was really how much? 110. So what is the fixed cost? How much should they charge me for the unlimited text, talk, and data? Wouldn't I take 110 minus 30? How much would we be paying? $80, right? Does that make sense? Okay. Now, this is what we call the fixed cost. Okay. Now, look, y'all, the third part of the question says, write the equation that describes the cost C in terms of the number of phones P. Okay, so look, we're going to figure out, if I wanted to have as many phones as I wanted, whatever number that happened to be, how much am I going to pay per phone? $15. So 15 times P, however many phones I have. Plus, if I want that unlimited talk, text, and data, how much am I going to pay also? $80. This right here, guys, did it make sense how we were able to solve that problem? These are the kinds of questions that I saw on the test. They're asking you, can you break down the information and write it in a basically an equation? So we know we're paying $15 per phone. If I had 2 lines, that would have been 30 bucks, but my bill was 110, but my bill should just be $30. That means the difference, 110 minus 30, the 80, that's how much I have to pay regardless of how many phones I have. Okay. And now I have an equation that says, look, if I want to get 10 phones, I can figure out how much my cost is going to be. Okay. All right. Look, y'all, I got another problem here. Directly TV. You like how creative I was there with that one? Directly TV is a cable company that charges a fixed amount for a basic cable package and additional fee for each premium channel. Use the information in the table below to answer the questions. Look, guys, if I had 3 channels, 3 premium channels, I was paying $85.99. If I bumped it up to 5 channels, I was paying $109.99. How many additional channels did we get? 2. Okay, so look, we know that we had 2 more channels. How much money did we end up spending additionally? Yeah, $109.99 minus, what is it, 85? We paid an additional, what, $24? Okay, so how much did they charge me per channel then? $12. Okay, yeah, $12 per channel. Does that make sense? How we're able to figure that part out? Okay, again, you guys, I can't just take $85.99 and divide it by 3. Because if I try to do that, or if I try to do it with a 5 and 109, I'm going to get different answers. Now, they want to know, the second part of the question is, how much do they charge for basic cable? Well, look, y'all, if I have 3 channels and they charge me $12 per channel, how much should I be paying for those 3 channels? $36, right? Does that make sense? If I have 3 channels, right here, for those premium channels, I should be paying $36, but my bill is how much? $85.99. So what I want to do is I want to subtract off those $36 so that I know how much the basic cable package is, right? So look, $85.99 minus $36, what, $49.99? Did that make sense how we're able to figure that part out? Am I doing okay so far? The 36, so right here, do you see how if I have 3 channels and they charge me $12, wouldn't I be paying $36 for those 3 channels, right? But I know that my total bill was how much? $85. So if I want to know, suppose I didn't want those 3 channels, right? I wanted just the basic cable package. I would say, well, if it's $3, if it's $12 per channel and I got $3 for the basic cable package, I'm going to take this $85.99 and I'm going to subtract the 36. And that tells me that my basic cable package would be $49.99, right? Look, y'all, I want to say there's a part C. I'm sorry they didn't come out nice and pretty. The C is way down at the bottom. But let's see if we can write the original or an equation, right? How much am I going to pay per channel? 12. $12 times P, whatever P is, the premium channels, right? Plus, how much is my basic cable package? $49.99, right? Y'all, again, what I wanted to mention here, these are the types, this is how they ask a lot of the questions on the test, okay? And really, I think part of it is you're reasoning your way through the problem, okay? All right. Let's see if we can answer the next couple of problems, guys, and then we'll go back to the main little handout that I gave you guys, okay? So, guys, I'm going to zoom in here a little bit, and it says cars typically depreciate at an annual rate. Depreciate means the value goes up or the value goes down. Down, right? Okay. So it says use the table below to answer the following questions in regards to a 2007 Dodge Ram 1500 quad cab pickup truck. Okay, so this is what it's telling me. After 3 years of owning it, the truck was worth $16,200. After 6 years of owning it, the car or the truck was worth $9,900. Can we figure out how much it went down by? Wouldn't we subtract those numbers? 6,300? Okay. So y'all, in those 3 years, it went down. Guys, because it went down, negative 6,300, right? Because it lost value. How much time passed from 3 years to 6 years? 3 years. Okay, could we figure out how much money it's losing per year? What would we do? Divide it out. Okay, guys, if you divide it out, how much is it losing? Negative how much? There you go. Okay, why is it negative? Because it's what? Going down. It's depreciating, right? Does that make sense? Okay, we want to know how much was the vehicle worth when we first bought it, okay? Let's think about that, guys. I want to know how much was this truck worth when we first got it? Let me ask you a question. After 3 years, it was worth how much? 16,200. If I want to go back 3 years before, and if it goes down by 2,100, what do you think I should do? Okay, let's multiply 2,100 by 3, which we're going to get 6,300, right? And then what would we do? We would add it back to this number here, right? Because we're going backwards. Great, y'all. Y'all are doing great. So look, 6,300 plus, what was it? 16,200? 22,500? That's how much it was worth when we first got it, right? Because what am I doing? I'm adding 2,100 3 times because I want to go back 3 years. Does that make sense? Okay, guys, now look what it says. Write an equation describing the value of the vehicle V in terms of the number of years T. Yes, ma'am. Yeah, because remember, the car was going what in value? Down, right? So after 3 years, it was worth 16,200, right? But if it went down $2,100 per year and I wanted to go back 3 years, wouldn't I have to add 2,100 back 3 times? Because if it was going down $2,100 every year, 3 years before, I would be adding another 2,100 because I'm going to be going backwards. 6,300, right? Plus the 16,000, and that's how we came up with the 22.5, right? Okay, so guys, let's do it like this. When we first bought the truck, how much was it worth? 22,500. Every year it goes down by how much? That's why there's a minus 2,100, y'all, with a T, depending on however many years it takes. Okay. And that's it. Again, all I'm trying to do here, guys, these are linear relationships. So this stuff is still like, I want you to think about this for a minute. Remember when we did y equals mx plus b? Okay. This here, guys, is my b. That right there is my m. That's the rate at which it's changing. it's going down. So it would be starting up here at 22,500, and it's going down, right, in value, 2,100. Okay, let's try another one here, guys. I'm trying to do the same sort of process here. Mondo has started an exercise and workout regimen so he can lose weight. Use the table below to answer the following questions. Okay, so let's take a look here. At week 5, y'all, Mondo was weighing at 185.5 pounds. In week 10, he weighed 178.8 pounds. Can we figure out how many pounds he lost? What do we do? Subtract them, right? Okay, so look, let me grab my calculator, guys. What do y'all agree? 185.5 minus how much? 178. How many pounds did he lose? 7.5 pounds. He lost 7.5 pounds. Guys, because he lost it, y'all agree negative? Okay, how long did it take him to lose that weight? 5 weeks. Okay, can we figure out how many pounds he's losing per week? How much? 1.5, right? He's losing 1.5 pounds per week. Okay, guys, can we figure out how much Mondo weighed in the beginning? Okay, let me ask you a question. We know that after 5 weeks, he weighed 185.5. Can we go 5 weeks back to figure out how much he started off with? Okay, so bless you. Would you guys agree we got to take 1.5 times 5, which would be what? 7.5 pounds, right? Now, if this is how much he weighed at week 5, what would we have to do with that number and this number here? Would we subtract him? Would he weigh less or would he have weighed more? He would have weighed more, right? Because he was losing weight. Okay, so look, guys, we're going to take 185.5 plus 7.5. How much did Mondo originally weigh? Y'all, am I making sense with any of these problems? Okay. Look, the last part, guys, says write an equation that describes Mondo's weight M. So, okay, look, how much is Mondo going to weigh? Well, how much did he start off with? 193. Minus, because he's losing weight. How much does he lose every week? 1.5 per week. Okay. And so now, guys, if we said, look, how much is Mondo going to weigh in 20 weeks? We could figure that out, right? But again, these are the types of problems that I saw on the test, guys. I think the most, like, look, a little while ago when we drew the line, right? When we did that, is that important? Yeah, you're going to have to do stuff like that. To me, this is where this stuff comes into play, because if I can't use it anywhere, well, what's the point in learning this stuff? And this is where it comes into play, okay? Let's see, guys, I'm going to do the same sort of problems here. Just a couple more problems, guys. 1, 2, 3, 4, and then we'll do the last bit about square roots, okay? So we'll be done a little bit, guys. I know it's a lot. I wish it was less. Look, guys, let's take a look at this problem here. It says a plumber charges $23 an hour for house calls plus a service fee of $40. Okay, let's see if we can write an equation. Okay, so guys, if I call up the plumber, before the plumber even shows up, how much am I going to have to pay? $40, right? Okay, let's do this. Let's see if we can come up with an equation for the cost. Before they show up, I got to pay $40, right? Because that's the service fee. Whether they're there for 10 minutes or whether they're there for 8 hours, you got to pay $40. Every hour that they're there, you're going to pay how much? So $23 per hour. Does that make sense? Okay. Now, look at the next question. The next question says, what would the cost be if the plumber worked for how long? 3 hours. Okay, well, we already know we're going to pay how much? 40. Plus 23 times how much? 3. Okay, guys, order of operations, you'll agree we should do 23 times 3? Is that 69? What's 40 plus 69? 109? There you go. That's how much we got to pay if the plumber shows up for 3 hours. Guys, look at the next one here. The plumber sent an invoice for $224. How much did they charge us for? How many hours? Okay, so look, y'all. My total bill was how much? 224, right? When the plumber comes, regardless of the time, how much am I going to pay him? Okay, so do you guys agree we should subtract that 40 off? Okay, let's do this. 224 minus 40. How much? 184, right? How much did they charge us per hour? What should we do with the number 23? There you go. Divided by 23. 8 hours? There you go. 8 hours, guys. Y'all, I know that the stuff with like y equals mx plus b, sometimes like, man, what is all that stuff for? This is actually y equals mx plus b. It's just like in practical terms. I think a lot of times, y'all, in education, we focus on, okay, can you do these basic skills? And sometimes the basic skills make the problems harder than they need to be because you guys were able to figure this out without really any worrying about y equals mx plus b stuff. And in actuality, that's what it is. Guys, we actually did the problem here with the desks earlier. We did this one. So look, let's go ahead and ditch that one for now. But let's take a look at this one, guys. This problem here, very similar to the problem that we did with the truck a little while ago. Let's see if we can't figure it out. Okay. Let's take a look, guys. We're looking at a little bit of an older car, a 2005 Nissan Altima. Depreciates at a rate of $1,800 per year. Does that mean it's going up in value or going down? Going down. Okay. If the car has a current value of $7,200, find an equation in slope-intercept form that models the value of the car based on the number of years. Okay, so let's do this. The value of the car. How much is the car worth today? $7,200. But the car goes up in value or down in value? Down in value. How much? So minus 1,800, guys, with a T, because I need to know how many years I'm going to be using. Okay, that's what they're asking me to do in part A. Now, let's figure out if we can do part B. We want to know how much is a car going to be worth 2 years from now. So we know right now it's worth 7,200, but we got to take 2 times how much money? 1,800, because that's how much we have to subtract from it. So that's 7,200 minus 36. How much do we get? What's 7,200 minus 3,200? Still 3,600, right? Okay, guys, so the car lost $3,600 in how many years? 2 years, right? Now, look at the last question, guys. The last question says, how long or when will the car depreciate completely? Guys, when it depreciates completely, the value would be how much? 0. Well, let me ask you a question, guys. If in 2 years it went down by 3,600 and we still got 3,600, how much is it going to take to get down another 2 years? How many years is that total? Everybody agree that's a total of 4 years, right? Because we lost 3,600 in 2 years. If we lose another 3,600, that's going to be a total of how much? 4? Okay. All right. So guys, let's do this one here. And I guess we can do that one también. And then we'll just do the square root stuff and we'll be done. All right. So guys, 3 more problems. 2 or 3, whatever it is. Al starts a new diet and workout regimen. Al's a big guy, 286 pounds, and he's losing weight at a rate of 2.5 pounds a week. Find an equation that in slope-intercept form that models Al's weight based on the number of weeks X. Okay, so let's figure out Al's weight. Right now, how much does Al weigh? 286. Is he losing weight or gaining weight? Losing weight. So guys, if he's losing it, y'all agree minus? How much is he losing? 2.5 per week. Okay, could we figure out how much he's going to lose in 10 weeks? Okay, would you guys agree we're going to take 286 minus 2.5 times 10? Because we got to figure out if it's 2.5 pounds a week, we got to take 2.5 times 10, How much did he lose in 10 weeks? 25 pounds. So we take 286 minus 25. Is that going to be 261? There we go. So in 10 weeks, guys, Al's going to be down to 261. Now, let me show you the last part here, guys. The last part says, how many weeks is it going to take Al to reach his target weight of 240? Okay, y'all, this is what I want to do. I want to come back to this part right here. See how he wrote that part out right there? Remember what W stood for? W stood for his what? Okay, guys, what I'm going to do, I'm going to put a 240 right here. And I'm going to solve for W because W tells me how many weeks. Y'all, if I wanted to get the W by itself, how would I get rid of this 286? Okay, let's do that. 240 minus 286, negative 46. How would I get rid of my negative 2.5? Divide it. Okay, 46 divided by 2.5, make it negative. How many weeks are you coming up with? 18.4? Okay. Now, guys, I remember when I did this last semester, somebody said, should I put 18.4? Should I put 18, put 19? Unless it tells you to round, leave it as 18.4. Okay, leave it as 18.4. All right. Okay, so guys, I want you to look at this last problem that I got here, and then we're just going to do a little bit of square roots. We'll call it a day. It says the graph below shows the value of a machine used to make faucets, right? So water faucets, where Y represents the value of the machine in thousands of dollars after X years. Okay, what is the Y-intercept? Okay, guys, remember where the Y-intercept is? It's that line right there, okay? What would you say the coordinates of that point right there would be? I'll give you a hint. The first number is 0, 20. And that 20, do y'all agree that really means 20 what? 20, look what it says here, $20,000, okay? Okay. What's the Y-intercept? 0 and 20,000, right? What does the Y-intercept mean? That means that the value of the machine was originally worth how much money? $20,000, okay? Guys, is the value of the machine going up in value or down in value? It's going down. Okay, look, how much time passed from here to here? 1 year, right? How much passed from here to here? 1 year, right? 1 year each time, right? But it's year 2, but it's 1 year at each time. How much did the machine lose in value from here to here? Okay, so the value went down by $4,000 every year. Okay, so look, guys, we're going to write out our equation. This part here tells me my slope. So the value of machine, guys, is going to go down by $4,000 every year. How much was it originally worth? Plus 20, right? Why positive? Because it's up there on the positive axis, right? Guys, we could have written it also as 20,000 minus 4,000x. It's just telling me the machine is losing value every year, right? It goes down in value $4,000. Y'all, I'm going to look at this graph here. If I were to go down one more, wouldn't that be at 5? Right? If it's going 1, 2, 3, 4, wouldn't the next one be 5? And after 5 years, how much would the machine be worth? Nothing, right? Because it loses $4,000 every year. Does that make sense? Again, I'm just kind of looking at my picture. All right. Guys, last part here. I'm going to go back to my original book that we had, okay? And I'm going to scroll all the way down. All the way over here, all the way over here, all the way. More. I'm going to, here we go. Okay. Square roots, guys. Pythagorean theorem. Okay. This is the last part I'm going to teach you guys because, again, there's going to be certain problems, guys, where you're going to have to use the Pythagorean theorem. But first part of that's going to be square roots. Now, we're pretty familiar with square roots, y'all, because we looked earlier at our chart, right? So here's all my perfect squares, okay? Guys, let me ask you a question. Anybody know what the square root of 25 is? What about the square root of 49? Okay, guys, when you have a fraction, do it in pieces. What's the square root of 25? What's the square root of 36? There you go. Just do it in pieces. Piece at the top, piece at the bottom. What's the square root of 4? 2. What's the square root of 9? Anybody know the square root of 81? So far, so good? Okay. I try to keep it the easiest part, guys, for the very end, okay? Try to. Square root of 7. Look what it tells me to do. Approximate it using decimals. That's what I'm going to do, y'all. Here we go. On my calculator. Guys, on the calculators that they gave you, on your calculator, you might have to hit the square root button first and then your number. So on those calculators that they gave you guys last Friday, you would hit the square root button and then hit 7. On this calculator, guys, I'm going to hit 7 and then the square root. But are you guys coming up with 2.6457, all this kind of stuff? Okay, guys, if I'm going to go to 3 decimal places, the 5 is a number that I want to round. Remember, I got to look at the number to the right of it. It's a 7. So should I put 2.645 or 2.646? 646, right? 2.646. Okay. 54, guys, square root. So again, on your calculator, you might have to hit the square root button first and then the number 54. 7.348 or 349? 348. Good. So far, so good? Okay. Y'all, for these next 2 problems here, look what it says. Determine what 2 whole numbers each square root is between. Okay, guys, I'm going to come back. I'm going to look at my chart. Okay, yeah. Look at the number that I have here. The number I have here is what? 40 inside the square root? Okay, look at my chart here, guys. What I want to do, I'm going to go along my diagonal. 40 would be between what numbers along the diagonal? 40 would be between what? 36 and 49, do y'all agree? 40 would be somewhere right in here, right? But we know the square root of 36 is what? And we know the square root of 49 is? So that tells me that the square root of 40 has to be somewhere between 6 and 7. Yes, ma'am. Uh-huh. Okay, look at the decimal up there. How would you know if you're going to change it to a 9? Okay, what number is closest to, which one is 5 or more? You got to look at the number where? To the right. There you go. Guys, 13, come back, look at the chart again. 13 would be where along my diagonal? Between what 2 numbers? 9 and 16, right? But I know the square root of 9 is what? And I know the square root of 16 is? So this guy is going to be between what? 3 and 4, right? Does that make sense? I'm able to do that? Okay. Guys, the Pythagorean theorem. If you went to school anytime in the last 200 years, they probably taught you all the Pythagorean theorem, but it's been a long time. So we're going to go through this part here. Okay, guys, the Pythagorean theorem. Maybe you remember this: a squared plus b squared equals c squared. Maybe you do, maybe you don't. This is the important part. Where that little square is, the side across it, y'all, is always going to be my c. Which one do I call a and b? It doesn't matter. A and B can be the top one or the bottom one. C is always the one across from the little square. Okay. Here's a couple of problems. Find the unknown length in each triangle. Round to the nearest thousands. Okay. Look, guys. First thing I'm going to do here, that side is C. Okay. I'm going to call this guy here A. I'm going to call that guy there B. Okay. A squared plus B squared equals C squared. Okay. So look, y'all, I'm calling A to be what number? So I'm going to put 5 squared. B is going to be what number? 12 squared equals C squared. Okay, question. Anybody know what's 5 squared? 25. What is 12 when you square it? 144 equals C squared. Guys, 25 plus 144 is 169 equals C squared. Okay. Before I go on, are we good on how we got to where we are? Okay, guys, the way we find C is we take the square root of 169. Anybody know what the square root of 169 is? 13. Now you're done. Okay. Y'all, the important part, which one do you call A and B, is not important. What's important is where that little square is, that side, y'all, is always going to be which one? C. Okay. The other ones, you want to call one of them A, one of them B, the other one B, the other one A, doesn't make any difference. That part is going to be C. Okay. So look, guys, let's do this next one here. First thing I'm going to do, y'all, I'm going to write down my formula. A squared plus B squared equals C squared. Look, I'm going to try to keep it simple. I'm going to call that one A. I'm going to call that one B. Okay. So A is going to be 10 squared. I don't know what B is, guys, so I'm going to leave that as B squared. But C is the number what? 12? 12 squared. Good. Very good. Thank you, Miguel. Guys, 10 squared is 100. Plus B squared is, what is 12 squared? 144. Okay, guys, I want to get the B squared by itself. How would I get rid of that 100? Good. Okay, so now B squared equals 44. Guys, to find B, I'm going to take the square root of 44. Let's do it. 6.633. Okay, guys, it's telling us here we're going to round this to how many decimal places? 3. Okay, guys, question for you. 6.633 or 6.634? 633. Why? Again, we got to look at the number to the right of the 3. It's a 2, so we're going to leave like that, right? 6.633. And there we go. Okay, so guys, I got a couple more here. Again, I'm going to do the same thing. I'm going to write down my formula. A squared plus B squared equals C squared. Guys, the legs are my A's and B's. Okay. So look, I'm going to say A. A is 3. So I'm going to say 3 squared plus 4 squared equals C squared. What is 3 when you square it? 9. Anybody know what 4 squared is? 16 equals C squared. 9 plus 16, you guys, should be 25. So remember, C, guys, is the square root of 25. What's the square root of 25? There you go. Nice and pretty, ¿verdad? Okay. Look, guys, I think there's just a couple more. Yeah, a couple more to do, and we will call it a day. Okay. Guys, A squared plus B squared equals C squared. Look, I'm going to call that A. Hypotenuse, guy, that's my C. Okay. The hypotenuse is a C. So look, let's do this. A squared, I'm going to put 5 squared, bless you, plus B squared equals what? 13 squared, right? Okay. So 5 squared, everybody agree 25? Okay, B squared. 13 squared is 169. Okay, last step, or second last step, guys. How do I get rid of my 25? Subtract it, right? Good. Okay, 169 minus 25 should be 144. So guys, last step, B is the square root of 144. which is, there you go. All right, guys, I'm going to skip the one about the 10th, but I am going to do this one right here, the baseball one. Okay. Let's see. Guys, it says a baseball diamond is actually a square that is 90 feet on each side. Okay, so look, I'm going to do this. Okay. Everybody agree those are 90s like this? Okay. Let's see. If a catcher throws a ball to second base from 14 feet from home plate along the line to third base, how far would the catcher's throw be? Okay, so I'm going to read that part real carefully, guys. Look what it says. Catcher throws the ball to where? Second base. And he's where? Okay, so here's home plate. We're going to go 14 feet that way, right? Okay, he's going to throw the ball to where? Second base. So here's second base. He's going to throw the ball this way. Okay. How far would the catcher's throw? How far? Okay, 14 feet from home plate along the line to third base. What does that mean, along the line to third base? Yeah, let me see. Okay. Okay, so the catcher is, you know what? Let me do this, guys. I got to read the problem carefully. Catcher throws the ball to second base. He's 14 feet from third base, right? So he's over here, and the distance from here to here is 14, right? There we go. Thank you so much. And we're throwing the ball that way, aren't we? Okay, so we want to know, what is that distance right there going to be? Thank you so much. Okay, guys, y'all agree that that side is my C? Okay, so look, guys, this is 90, this is 14. So A squared plus B squared equals C squared. So look, let's call this A, let's call that B. So 90 squared plus 14 squared equals C squared. Okay, let's take our calculators. What's 90 when we square it? 8100? Okay, 8100 plus, what is 14 when I square it? 196. Okay, equals C squared. Y'all, what do I need to do with those two numbers? Add them together, right? Okay, so look, 8100 plus 196, 8296. Guys, to find C, what do I need to do? Okay, I'm going to do two things here, y'all. Let's go ahead and take the square root. Square root. Guys, if I go to three decimal places, am I going to write 91.082 or 91.083? 82. Okay, 91.082. All right. This here, y'all, is my approximation. That square root is what we call our exact answer. Okay. The reason why we call the 91.82 the approximation is, again, y'all, when I look at my calculator, do you see how there was a bunch of numbers after the 2? We approximated it, right? We cut it. The exact answer is that funky square root right there. And that's what they're asking me to do for that part. Okay. All right. Whew. That was a lot of stuff, guys. You can already hear my voice is going out. So look, I'm going to do this, guys. I'm going to stop recording this, okay? So stop recording.